Okay, so the first thing you need to know when dealing with a resolver that is not predefined in the system is the number of resolver poles, not motor poles, not motor pole pairs, but the actual number of resolver poles. So to do that, go back to the analytics screen where I am right now. Under resolver, we don't care about the number of motor pole pairs at the moment, so I'll just leave it or put it to 2. But under manufacturer, you're going to select this ABB 3HAC 8 pole. Now, the reason that we select the ABB 3HAC 8 pole is that this particular designation is good for a baseline because that is a single pole resolver code in the actual software. So select that ABB 8 pole. Again, set the parameters, and you can still leave it at 6 volts, 5 kilohertz, and start collection. And then on the shaft of the motor you are working on itself, again, designate a 12 o'clock point or a starting point, whether it's the keyway right at the top, whether you have to take a marker and make an indication. But you're going to adjust the shaft until the mechanical angle is at 0 or very close to 0. Then you're going to make that mark. And then as you do one full revolution of the motor shaft, you're going to watch that mechanical angle to see how many times it goes to 0. So right now I have my shaft designation at 12. I'm going to start moving the motor shaft clockwise. That's my first 0 point right there. So that's 1. 2. Three, and 4. And now my shaft position is back at that 0 position that I started for one full revolution of the motor shaft. So that mechanical angle cycled 4 times for one actual rotation of the motor shaft. So that tells me using this code, this one pole code, that this resolver on the motor that I'm working on is actually a 4-pole resolver. So with that information, I'm going to stop collection. I'm going to go up here to edit and preferences. And then over here on the right, make sure add motors is selected. The action you're going to pick is add. You're going to enter the manufacturer part number of the motor here under new entry. You can see I was doing this earlier. So just to make it new, I'm working on a KUKA 1FK. And right here, enter the number of resolver poles, which we just established was 4. Under low volt, that is almost never going to be checked. I was saying earlier that most resolvers, the sine and cosine signal strength for good resolver should be at about 48% of the reference voltage. There are resolvers out there that have a smaller output, 250, 500 millivolts, where the sine and cosine strength is only going to be about 25% of the reference voltage. So the way you would predetermine that, unfortunately, is just by looking up a data sheet online of the part number of the resolver to verify. Also, if you assume that it's not low voltage, which you should, because most of them aren't, most of it is that 48%. And you do an analytics test and you notice in those data points on that report that instead of being about half, it's about 25%, then you would go back and change this to low voltage. But again, most of the time it's 48%, but that low voltage toggle is there just in case you're dealing with one that is not. The lock-in, you're just going to set an arbitrary lock-in for now, and I will explain why in a moment. And then the commutation offset is usually going to remain at 0. There are rare motors with resolver feedbacks out there where there is an offset. Instead of the lock-in being exactly 0, it'll be 5 or 10 degrees instead of 0. So that's why that commutation offset is there. But for now, just leave it at 0. And then once you have that filled out, you're going to hit update. And save. So now, if you just want to check real quick that it went through, again, we don't care about the pairs yet. You can see my KUKA 1FK2 is now in the drop-down list, but we are still not quite finished. So I'm going to go back to our motor and lock-in screen and make sure that my motor power connector is hooked up to the alignment. I am going to select the resolver motor that I just created in the dropdown. Again, not really caring about the motor pulse. And I'm going to set the parameters again. Start collection. So what we need to do now is verify what the proper lock-in is. So the way you do that is once you have collection started, you're going to move the motor shaft until the electrical angle is at or pretty close to 0. And you are going to start applying positive and negative voltages to the phases of the motor itself by using these toggles. So I always start with U positive, V negative. And then I observe the electrical angle to see how far away from 0 that got me. And then I will do W positive to see if it gets closer or farther away from 0. In this case, it went farther away. So I'm going to reverse that and change it to W positive. And you can see now I am closer to that 0. Now, since I have U and W positive, and if I were to disable that V negative, it wouldn't do anything. I'm going to switch U from positive to negative to see if that gets me closer. Oh, a little too far. So now I will disable current going into U at all. Nope. And it looks like we're just about there. All right, so that is my correct phase lock-in for the alignment for this motor, which is V negative, W positive. You can see that because with the rotor locked in that sequence, I'm crossing over that 0-degree electrical angle and it's resting at or pretty close to 0. So you never want to remove a feedback device until you know what that lock-in is. Most of the time, it's going to be predefined in our software already if it's a feedback type we support. But in this case, when you're creating a new one on your own, always want to make sure you know what that alignment is before you remove the resolver. All right, so now we know that the lock-in is V negative, W positive. I'm going to stop collection. I'm going to go back to edit preferences in the add motors section. Instead of add this time, I am going to select modify. And from the existing motor list, I'm going to highlight my motor that I created. And I'm going to change the lock-in to the lock-in we just discovered. So V negative, W positive. Then I will hit update. And it will verify like, hey, you're about to change something, confirm operation, okay. It'll confirm in the status icon that it was modified, or the status bar that it was modified. Then I will hit save. And then from the lock-in screen, you can even go back and verify that by reselecting the motor ID that you created, set the parameters, start collection. And now when you hit the alignment toggle, either in here or the analytics screen, it will tell you what the lock-in sequence should be for that motor. So you've done it once. Now if that motor model ever comes through again, you have it saved to your AutoQ software, what that lock-in is supposed to be, the number of resolver poles, etc. So now you can go in, perform your alignment without having to do all the research that you just did that first time. So that is about it. Please remember, if you have any questions, run into any trouble throughout your testing, we are always available to help. Just shoot us an email at support@octavaengineering.com. Otherwise, I hope you found this helpful, and I thank you very much for your time.